Hello everyone. My name is Mario Dudjak. I will be holding today's workshop called Scientific Data Manipulation, and I will presumably hold another 3 workshops in this field. Maybe I can start with introducing myself first, then we can move on. I'm assistant professor at the University of Josip Juraš Strossmayer Faculty of Electrical Engineering, Computer Science and Information Technology in Osijek. I'm a member of this NextAIRE project as our faculty is one partner on this project. A little bit about myself. So I graduated from the same faculty in 2018 in computer science field, and then obtained my PhD in 2022, so 4 years ago. I'm actively working in machine learning and data science field, both in research and in development areas. So I published several journal papers, conference papers, also work on some R&D projects where I'm applying machine learning, data science to analyze and develop some kind of models. Today I will be holding this lecture. So my colleagues from the faculty who enrolled in this project initially asked me, because I'm, as I said, my research is basically data science, and also I'm teaching this kind of courses on at our faculty. So they asked me to make a couple of presentations, so workshops. And I think if you already been on some previous workshops, you're perhaps familiar with the whole platform. So we have a GitHub e-learning platform on the project's page. So I copy-pasted the link in this chat where you can find the materials for today's presentation. So we are now in module 3 or in data science field, module 3 of the whole project, which is called Scientific Data Manipulation. And this module is broken down into a couple of Jupyter notebooks, and we decided to skip the first one, but I left it in the GitHub repository, which is called NumPy and vectorization. But I will explain it later why we skipped and moved immediately on Pandas after. And actually, the first workshop in this module 3, scientific data manipulation, will be today's workshop, which is called Pandas data frame. Maybe I just to I think I copied a wrong link, so I will copy it once again. So today's lecture is actually the second workshop, Pandas data frames. So in today's workshop, we will first learn what is Pandas, what can be achieved with Pandas, why is it used, and then we will go through basic functionalities within this library that are used to analyze datasets in a lightweight manner, so to say. So in terms of basic statistics, data cleaning, data preprocessing, adding new data, filtering, aggregating, grouping, and so on. So the idea of today's workshop is to learn about this library and to learn also when using this library, learn about basic methods and techniques to which are often performed on the datasets, and how can you do it also by yourself in this programmatic way in Pandas or in Python. Okay, so you can follow along in couple of ways. You can select the way you prefer. So you can download the whole Pandas, the whole Jupyter notebook. So just go to the link I pasted in the chat and just download the raw file, and then you can go to any kind of environment for uploading Jupyter notebooks, but maybe the easiest one is Google Colab, which I will be using. So you can just go to Google Colab and then log in using your Google account, and then just in the upper left corner you have a file or whatever language you use. I use Croatian, so I have in Croatian. You can just upload your downloaded notebook, which is supposed in downloads. So you can just use it and download it. I already did that, so I won't be doing this once again. This is the first kind of first approach you can use to follow this workshop. The second one is maybe you can just go to blank Google Colab file, so you can go to Google Colab and make a new notebook, new blank notebook, and then just paste whatever I'm typing. And the third maybe approach is to use some other environment instead of Google Colab. You can use your local environment if you're maybe more tech savvy, or you will just stick to the Google Colab. I think used already Google Colab in previous workshops when you were teaching, learning about Python, basics of Python. So I hope that using this platform won't be a problem today. If you have some question now or some technical issue, maybe you can type it in the chat and I can help you before we start with the actual workshop. Is it okay if you is it okay for you to use this Google Colab? I won't push you to just to actually copy and paste all the code. I would prefer it for you to actively participate, but if you just listen and look, it is also okay. But this question is for those who will actively participate. Can you or will you use Google Colab or used? Okay, you used Colab in the previous lectures. Yes, I'm aware of that. Okay, so that shouldn't be a problem. You can just download the notebook from the GitHub and upload it to your Google Colab, and just start scrolling down. I also downloaded, but I remove all the code. So maybe yeah, but I didn't share it. But it was on purpose, so I can write code live, and I think it is better for you to look at the code as I'm writing it and explaining it rather than just looking at a bunch of code and I'm maybe it can be confusing at first sight. So I will just fill out these cells, code cells, with the same code as is on GitHub already. So don't worry, I won't. Maybe I will have some idea during the workshop to maybe write another line code, but 99% of the slide will be the same as is on the GitHub. Okay. Any other question before we start, maybe? No. So, okay, we can start with with the actual content. So today we will talk about Pandas. Pandas is a Python library, which is rather popular, and it is also simple and lightweight library. It is used mainly for data manipulation and mostly for tabular datasets. So the data or datasets that come in tabular form, so in some kind of matrix. This dataset should have some rows and also some columns. Rows usually represent instances in the problem, and columns represent characteristics of those instances. So, for example, you can have some medical data set, and then patients should be, each row should represent one patient, and each column represents some characteristic of the patient. Or, for example, you can have some financial data set. For example, you downloaded you obtained database from some bank, and you want to analyze, I don't know, credit scoring or credits for some clients or some kind of financial analysis. So in this example, the rows would represent bank's clients, and columns would be some kind of information about those clients, for example, salary, where they're employed, how long they're employed, and so on. Okay, I think you got the feeling what is a data set. So the data set in a tabular form is a great way to use a great I don't know, a great way to use Pandas Pandas library. Within this Pandas library, we have multiple different data structures, and I don't want to be too technical in this today's workshop. I will just briefly mention it and explain it. So you already, during previous workshops in Python, discussed about different data structures in Python, for example, lists, dictionaries, and so on. Today's data structures will be different, but are also compatible with the Python ones. So the main the main data structure in Pandas is called DataFrame. DataFrame, and it actually represents a data set. So the DataFrame is actually a data structure for the data set that so you want to use the data set in your program, in your Python, you have to upload it in some data structure, and DataFrame is used for that purpose. You will also heard when talking about Pandas about other type of data structure that is called series. But we won't go into much detail, so I will just briefly mention that series is simpler than DataFrame, that actually DataFrame is a collection of series. So each column in DataFrame is actually one series. It's similar to list, but not so one mapping, but it's similar. So actually one-dimensional data structure, where data frame is actually two-dimensional data structure. Sorry. Okay. So why is Pandas so popular? Mainly because of these features. So because of having data frames. So if you have some tabular data set, and most of the data sets in real life are tabular ones, you can easily upload it to Pandas data frame and start working on that data frame. Okay, then we can start by importing Pandas and building a data frame. I hope that you now have a basic understanding of what data frame is. So, okay, so before we start building a data frame, we have to first import necessary libraries in the code. So in this Google Colab, we have a Python notebook. I'm also aware that you already worked with this Python notebook, so they are interactive way of writing code where you can combine both code and text, as I did for today's lecture. So I have text cells and I also have code cells. You can visually see the difference where the code cells have this run button, and I can write Python code within these code cells. And why I'm mentioning this again? So usually when you start developing something locally, you go into programming and want to write your program, and don't use some online tools like Google Colab. You have to first create an environment. An environment, besides the operating system and programming language, usually consists of also necessary libraries. And you have to manually install those libraries using some kind of package manager, for example, pip or conda. And this is not necessary in Google Colab because Google Colab already has some kind of default environment set up. And within this environment, there are a bunch of basic Python libraries already installed. So you can just import it in your code. You don't have to manually install anything. And this is the great thing with the Google Colab, and why is it used in workshops or presentations for teaching purposes and so on, because you can focus on the code itself and not on creating the environment. Okay, so we now have these necessary libraries installed within this Google Colab. You don't have to worry about it. You just have to import it. So for importing, you have to write the code in the following way. So the keyword is import in Python, and then import what? Pandas. Pandas is a library, and it is okay to just leave it like this. So if you run code, the pandas will be imported, and you can use this library after in the code, just typing, for example, pandas something, some method, or pandas some type of data structure, data frame, and so on and so on. For example, like this. But what people usually do when importing this type of libraries is give some kind of abbreviation just to make your code more readable. And the most common way to import pandas is as this editor suggests, is just write PD, because this is like abbreviation of pandas. So I don't have to after write the whole word pandas data frame and so on. I can just write pd dot data frame. Okay. This is the necessary import for today's lecture, but we have to also import NumPy, and I will also call it NP for the same reasons. And what is a NumPy? So I mentioned already that today the initial plan is to first go through NumPy, and then after NumPy workshop, then we can go with the pandas. But we decided to skip the NumPy. Why? So what is a NumPy? The first question should be. The NumPy is also Python library that gives the Python programming language the functionality that it doesn't have by default, and that is working with vectors or arrays. So vectors or arrays are again some kind of data structure that is more common for lower language, lower level languages, for example C, C++ and some C Sharp or some kind of similar languages, but it is not within Python programming languages. That is a bit higher level. So Python does have lists, and you already learn about lists. You use them, and then they can be they are the most similar data structure, Python data structure, to arrays, but they are objects, and I don't want to go I don't want to be too technical. I will just say that these are objects in the object-oriented paradigm, and they are a little bit more complex than just arrays in lower level languages, because arrays are just one-dimensional like lists that have data and indexes, and that is it. While lists have also some kind of methods in object-oriented paradigm, and constructors, this and so on and so on. So somebody developed this NumPy library where the vectors, the simpler vectors from lower level languages such as C, are transferred to the Python. And NumPy is also the very famous library because of that, because it provides an efficient use of one-dimensional data structures, and it is more efficient than lists, and then can be handy when you have a lot of data. And after NumPy, the Pandas was developed, and Pandas was developed on top of NumPy. And that is why we have to import both Pandas and NumPy to use Pandas. So without NumPy, Pandas is not working, but we don't have to actually know in too much detail about NumPy to use Pandas. And that is the reason why we decided to skip the workshop about NumPy and just move straight to the Pandas, because we don't want to confuse you. So regarding the NumPy, I think this will be pretty much all the mentioning of this library. Maybe we will also use some specific functions from NumPy for some specific purposes, but you just have to remember that Pandas is built on top of NumPy, and it's necessary for it to work, and that's it. Okay, we can then create the first data frame. We will initially create a data frame inside the code, but later I will show you how you can use some tabular format, for example, comma separated value, CSV, some kind of file that you can just upload to your Google Colab, and then read it using a data frame, Pandas data frame. Okay, for starters, we have to initially create a Python dictionary. The dictionary is created using this type of parentheses, and within these parentheses we have to or curly brackets, we have to make a Python dictionary structure which consists of keys and values. Here, when we will later convert this Python dictionary to data frame, and here we have to understand that the keys of the dictionary will actually represent column names. So if I write, for example, ID and give a bunch of IDs, then I will just create a column ID. And if I just write, for example, name, I will have a column names. So I will use the examples that are on GitHub that were developed to mimic the whole project scenario, and that is environmental sensoring, so some type of data that regards to air quality and so on. So the first column will be named station. So let's suppose we have a multiple measuring stations, A, B, and C, that that have collected some measurements regarding the air characteristic, for example, temperature, humidity, how much it rained, and so on. So although we have just three different stations, it is not okay to just write A, B, and C, because then we will have only three rows. We are now how to say it, filling. We are filling this column row by row. So if I write A, then in the first row of the column named station, we will have a letter A. And I can have multiple measurements for A. For example, like these two measurements. I can also have two measurements for station B, and I can have two measurements for station C. Okay, that is the first column. The second column can be the date on which the measurements were performed. For example, 2026 and the 1st of May. Then the second day, the 2nd of May, and I can just copy this for the rest of the list, because for all three stations, A, B, and C, let's say that we did perform some measurement on the 1st of May and the 2nd May, and then also did that for the second station and for the third station. So we just have two different dates that are spread across three stations. That is why we have to have 6 values within this values list, because there are 6 measurements. Okay. Feel free to interfere if you have any question, if something is not clear, and I will immediately answer it, because I have chat open on the other screen. It's better to solve any kind of confusion right away than waiting. The next column can be, for example, temperature. We also have to have 6 values, because, as we discussed, we have the 3 different stations measured on the 2 days. And then you can make up some kind of numbers. So I will just copy the numbers from the notebook. Okay, these can be measurements, temperature in Celsius on some kind of not so hot and not so cold days. It depends on the location. And then let's say that we have also humidity. Humidity column, but I will change the numbers because they should be represent realistic humidity values. So I made up some really high humidity values, not too much, but okay. And then, for example, we can also measure how much it rained on those days. For example, let's say on the first day it didn't rain at all, then the second day just a couple of millimeters per square meter. Then let's say it didn't rain on this station also. Okay, and this is almost the finished data frame, but we just created a Python dictionary. It is still not a data frame because I didn't use Pandas anywhere. So I can, for example, run. I didn't run the first. Okay, I'll run first imports. Then I can run this cell, and it will just print out this Python dictionary. It gives me what I inputted, but it is not in pretty formats for me to later use some kind of processing techniques. So I will transfer this data dictionary to Pandas data frame. And the most common name for Pandas data frame is not so imaginative, so it is just DF, like short for the data frame. And how is it created? We can call Pandas. So I will use the abbreviation PD, and then call the constructor for data frame object. The data frame is some kind of class, and I will create a data frame object. And in this constructor, I will just pass my data dictionary, Python dictionary. So this is the dictionary I created with some kind of dummy data. Okay, not so dummy. There are some realistic but not real measurements. And I filled this dictionary. I pass it through the constructor of data frame object, and then the data frame will be created. And I can make sure of that just by printing the df, not in the print function, just by stating its name. So I can just write df, the variable name, and then this will give me a much nicer result. The numbers are the same as were in the data dictionary, but this data frame is pretty more organized because these it is clear that these are the columns. So station is a column, date is a column, temperature, humidity, and so on. And also there is one column that we did not add on purpose, and this is these are indices of rows. So this is the first row. In programming, the first index is always 0. So this is index row with index 0. This is index 1, and so on. So we have 6 rows, 6 different measurements for 2 stations on 2 different days with some kind of data for temperature, humidity, and rain. And this is the data frame. For example, let's pretend this is a data set we collected during some kind of project where we actually bought some kind of equipment, used trained experts and so on, and they collected the data, and the data has come to us. So we are data science experts, and we want to first upload it to data frame. We want to create a data frame and see how the data looks like. So the data here is clear. There are no problems with the data. In the second workshop, so not in not today's workshop, we will discuss what if there are some problems with data. So for example, you don't have all the data, some temperatures are missing, or there are wrong values. For example, let's say that temperature is minus 50 Celsius, but you know that this is not realistic, or it is even not a number. For example, you can say B, and these are some common problems that can happen when once creating a data frame, and we will discuss it in a next workshop. But for today's, we will assume that the data is clear, it is perfect, so we can start looking at this data using Pandas. So I will once again repeat that each column here just represents some type of variable. within the dataset. So we have measurements variables, informative variables, while each row represents one observation, one instance, so one measurement. So we have 6 measurements of different characteristics. Okay, this is the most common type of data set in all domains that you can imagine, not just in air quality, but in medicine, finance, I don't know, natural sciences, social sciences, so on. For example, in social sciences, you can perform some kind of questionnaire or some type of research and collect data, and the data will be put in some kind of table. And you can also analyze this data in Python using Pandas, and it will initially look similar to this. So it will have some columns and some rows. Okay. Okay, now when we have our data frame, we can start by doing something on the data. Let's first inspect the data. So what does it mean to inspect the data? So we have only 6 measurements, and we can inspect the whole data set just by looking at those 6 measurements. We don't actually need some sophisticated methods, but let's suppose that we have 6,000 measurements or 600 or some kind of number that is not that you're not feeling positive to looking at every row, and you can't conclude anything from that. So in these kind of situations, which are more realistic, you have to have some initial look inspection of the data without looking at each row. So Pandas offers you basic methods for that. So you have to ask yourself, for example, what columns do I have? How many rows do I have? What kind of columns are there? So are all numeric columns or are some non-numeric? Do I have some problems with data? For example, are there any missing values or some outliers, and so on and so on. Before doing any of that, you can just inspect first couple of rows just to have get initial feeling of the dataset. And how is it usually performed in Pandas? Using the head method. The head method, the name of the method speaks for itself. The head, like the head, prints the top n rows. By default, first 5 rows, if I'm not mistaken. Yes, so first 5 rows. But you can just put this here on whatever number you want. For example, you can, let's say I want to just print first 3 rows, or if I write the bigger number here, it won't matter because I only have 6 rows. But imagine you have 6,000 and write 15 here, you will see only the first 15 rows. So the head method just prints the first n rows when n is by default 5, and you can use any kind of n you want. And this just gives you initial feeling of the dataset. So it states what are the columns, how many are the columns here, how the data looks like, and so on. And after you get an initial feeling, you can ask for more information about the data frame from Pandas using the info method. Info method is short for information. It is done on this data frame as head was on also done on the data frame. And when I run this code cell, I get basic information about my data frame. What kind of information? So it it states how many rows are there. So I have 6 rows. What are the indices of those rows? So usually they are from 0, moving incrementally. And I also have 5 columns. So these are 5 columns. And then it gives me a list of all columns. It is a very useful thing because later, if you want to perform some kind of mathematical modeling, for example, regression analysis, I don't know, basic statistics, or so on. So most techniques only can perform this type of analysis on numeric columns. So, for example, you can't calculate the average of this column, of station column. Maybe you can think of something, let's say, alphabetically, but it's not a common way of calculating average, and the pandas will give you an error. So the code will break and you will get an error because you try to do an average of a non-numeric column. So this info method just explains to you what columns are numeric and what are non-numeric. This can be seen from the last column here, which is called D-type. D-type is just a name for the types in Pandas. So if it says float, these are real numbers. Int is short for integer, so integer values. Like humidity is not a real valued, and it certainly is not, but temperature and rain are. And about regarding the station and date, so these are non-numeric. One may argue that date is numeric, but it has these dashes between, so this is not strictly saying numeric variable. So it says that it is an object, and objects are non-numeric. So they can be maybe transferred to some numeric number easily, maybe not so easily, but they are not by default numeric. So date is not by default numeric. And you should be aware of that before doing any analysis. How many columns do you have and what type of columns do you have? So we have 5 columns here, 3 are numeric, 2 are not. And also non-null, that means that there are missing values within these columns. So each column has all values. Each column has 6 values. And that is a good thing. So we have a clear data set without any missing values. It also says how many bytes does this data frame use. Okay. After info, one of the most common methods used to analyze at the first hand your data frame is describe method. It is used in the similar way. So I just call describe on this data frame, and then it gives me descriptive statistics, so basic statistics. So I think you're all aware of basic statistic measures. For example, mean, that is like an average or mean value. So it calculates the mean. It also says how many are values there. It also calculates standard deviation, and then distribution in terms of quartiles. So minimum value, maximum value, first quartile, second quartile, and third quartile. What is the maybe the more common way of denoting this value that is called here 50%? Does anyone have some idea how can we also call this measure? So this is the measure that is larger than 50% of the data while also being smaller than 50% of the data. How is it called in statistics? Median, yes. Median value, yes. So this is just a median value, but we can also just maybe if we want to call median, we can just yes, but not on all data. For example, I'm now just one step ahead. Sorry. We can specifically calculate median, but not on the whole dataset, because the dataset doesn't have all numeric columns, but we can, let's say, temperature, but I'm now one step ahead because I didn't explain what this means, but I wanted to say show another way of calculating median value. So you can calculate it in this way, just by explicitly stating median. But if you're not, you will maybe do this if not aware that using describe, the median is already calculated, and it's shown here just by label 50%. Okay. So these are basic statistics, and that can come handy when talking about your data set in some general have some general discussion about your data set. So you can say, for example, I have data sets of different measurements, and the average temperature on all those locations is 19 Celsius degrees Celsius, and medians is similar to the average. The temperature is in the range between 17 something to 20 something, and you can say a couple of facts, general overview about your dataset just by reading from the output of the describe method. Okay. Okay. I see that you're listening because you most of you, so many of you answered this question correctly, and also within this inspecting data, I want to show you one more thing, and that is you can print all your columns, column names, because in previous methods, just the info method returned the column names, but they are packed in this complex, fairly complex output. Maybe you want to just derive the list of column names, and you can easily do that, for example, like this. So I will ask my data frame to give me the columns and to pack it into Python list. So I asked my data frame, what are your columns? And it gave me its column, and I packed it into list and just print it within the print function. So the columns are these ones. And one thing that you should be aware of is also the shape of data frame, because it will mean something in the later methods. And what is the shape? So shape is it's not a function, it is a property. So without this parenthesis, shape is like dimensions of your tabular datasets. You can look at your tabular dataset as some kind of matrix. So matrix has some dimensions in terms of number of rows and columns, and this is the same. This shape has the same meaning. So our data frame has shape 6, 5. So 6 rows and five columns. And this is important to understand because in some kind of mathematical techniques, you will have to provide the shape. So either you are working with rows or you are working with columns, and you have to be aware of that. So when we are talking about shape, we are talking about the 2 dimensions, so the number of rows and number of columns. Okay, so we derived, so we created the data frame here directly from Python dictionary, but we can also do it in different way, just by loading the data from file, some kind of file. The most often type of files used to save tabular data is CSV file, comma separated value that can be easily opened with Excel, but it is also easily opened using Pandas. So you can create or have some kind of CSV file, maybe somewhere on the computer, and within this Google Colab, you can click this button here on the left side that represent file directory, and you can upload your CSV file here in your file directory. So just click here and find some CSV file and put it here, and then you can in code just you can write read CSV file, and I will do that, but not by uploading the CSV file because I didn't prepare it, but I can mock it with the code. So I will just copy this code from the GitHub, just to save time, and I will briefly explain it. So imagine I have already some CSV file on my computer that has this structure. So these are cells in this CSV file. CSV comma separated values, so each value has to be separated with comma. And I have some this type of file, and then I can just import it into Pandas by reading using a function read CSV. So I write Pandas read CSV and then provide a path to this file. I provide the path to this file, and then it reads a file and put it into this df underscore CSV, because I called this data frame differently just to make distinction between the previous one with the previous one. So this data frame will also look similar to the previous one because the data is in similar form, but this data frame only has three measurements. I can do it also by this. For example, I can open notebook, copy these files, copy this content, save the file as CSV file, for example, somewhere in downloads. That I will call it data.csv, and I will show it to so we can click here file directory and right click on the sample data, upload. I don't expect you all to follow this step because it is already covered, but I want to show you a different way. So I can just upload it here, and it is here, and I can write actual path that is sample data data.csv. Okay, and I get the same result. So I hope that you understand that I did the same thing, but this was in the code. So I copied this structure in the notepad, save it as CSV file on the in the downloads directory of my computer, and then upload it here. And it is now here in Google Colab. You can see it. So it is within this directory called sample data. It is called data.csv, and I can just provide the path to that file. So I can read data.csv. Okay, and this is the usual way of actually loading your datasets, because if you're working on some project and you derive some measurements, presumably you will first put these measurements within some kind of CSV file, text file, some kind of file. You will not write it directly into Python. That will be not so serious way to do that. So you will put it in some kind of file, and then after you will just upload that file in Google Colab or any other environment you're working in, and write Pandas code for reading that file, like read CSV. There are also other functions besides read CSV that enable practitioners to load different formats. You can read Excel files that are finished with .xlsx, and also text files, ARF files, some binary files. So there are multiple functions to use, but the most famous one is read CSV, because the data is most often stored in CSV format. Okay. I hope that is clear. So this is alternative, or perhaps I should say the standard way of uploading the dataset. So we will now do some kind of selection techniques on the data frame, but we will use the first data frame because it has slightly more values. So it has 6 values, and this other has only 3. So we will show you the necessary things you should know when working with Pandas that should enable to select only a subset of your dataset. So, for example, you want to just select one column. For example, you want to select only the temperatures. Or you want to select one specific measurement, so one row. Or maybe you want to select multiple columns and multiple rows that are all valid combinations, but we should learn how to do that. So we actually have to learn about selecting or indexing our data frame. So we can select, as I said, either one column, several columns, one row, several rows, or both. Make selection some rows and some columns. The easiest of all those described is indexing by column, because by default, if you just write in squared brackets your the name of your column, for example, as I did here. So I wrote df and then in square brackets the name of the column temperature. I will get lists, or maybe I should be more precise. I will get a series. If you remember it from the beginning of today's lecture, I mentioned this other Pandas data structure, and that is series. So I get one series, Pandas series. So it is a one-dimensional data structure. because the column is only one dimensional. So we only have one set of values. So these are all temperature values and are all indexed. So we can after selecting only one column, we can also look at it as some kind of list and do the functions that you already perform on the list before. Maybe select by index, so I can select the by index 0, index 1, or I can count how many values are less than 20, or I can calculate average, or I can maybe find maximum value, or find minimum value, or perform some kind of operation of that column. That we will do that later, but for now it is okay just to show how to select one column. So the selecting of one column is the easiest way of filtering the dataset, of selecting the dataset, subsets of dataset. So just put in the square brackets the name of your column. You can also select multiple columns at the same time, but it is necessary to put this list of columns inside double square brackets. That is the syntax. So for example, I can write station, temperature, and humidity. So I will get only 3 columns. So I selected a subset of my dataset that has only 3 columns. And how did I do that? I just wrote the name of the columns in double square brackets. Okay. So the selecting by column names is easier than selecting by row names, which can be odd for the beginners in programming, but it is like that in Pandas. So indexing by row indices is not so straightforward. For example, we can't just write wait, I will put it here. We can't just write this. For example, I want all rows between the index 0 and 3. So first 3 rows, or I can maybe just write 0. So this looks like I want to only first row. But if I run this code, it will give an error because it will say key error 0. So the invalid index error key. So it means that you don't have the column called 0. So it goes through columns and it looks for column with name 0, and such column does not exist. So it gives me an error. So by default, this type of indexing is only preserved for columns. If you want perform indexing on the rows, you have to write this thing here before, and that is called elots or index locate. So lots is short for locate, and E is like short for index. So locate by index. That is what it means. So locate by index, and you can provide a range of indexes. So if I write from 0 to 3, I will get only the first 3, and and you can see how we wrote 3 here, but it not include the row with index 3 because that is the typical Python behavior. If you write some range, it will start from the first number, but it will go all to the highest the second number, that means maximum number in range, but it will not include it. So it will just use the indexes 1, 0, and 0, 1, and 2. But if I write here from 0 to 4, it will include index row with index 3. Okay. And I also said that you can select your dataset both in terms of columns and rows at the same time. So how can you do that? So there is a different and similar different method with similar name. It is called locate, short for locate. It doesn't have this y before, because it does not locate merely on index number. It allows for more complex kind of locating. So it is usually used when you want to subset of your data, both in terms of rows and in columns. So I will copy it from the GitHub, this type of example, and paste it here. So for example, let's say I want only first 2 rows and only these 2 columns. So I write first 0 to 2, that means in terms of rows, and then in square brackets, I put all the columns that I want to have. So I now have a subset of my dataset that only has 2 it's I was not aware that it will return also the row with the index 2. That means it has a slightly different behavior than the previous method, because I explained how here it goes to that range, but it does not include this index, and here it includes it. So this is also one type, one more distinction with these 2 methods. So locate includes the whole range, while elots, ilocate it does not. Okay. Now we know how to make subsets of our datasets, and it is a very useful thing to do, because in most of the cases in real life you get quite large data set, and you don't want all information that you have. You want to just make some subsets to make some modeling, and you can do that both in terms both on the row level and on in the column level, and I show it to you how you can do that. Okay, I suggest that maybe we can make a 5-minute break now. I think we can continue. So we now learn how to design or develop data frames that mimic actual data sets, and how to make subsets of data sets, and also how to load the real data sets from some files into your data frame. And also how to describe your data set, so using basic describe and info methods. This is not all that Pandas can do. Pandas can do many other things, and I want to during today's workshop want to also show you a couple more things. So the next thing we can show is how to perform filtering, and the filtering here means also selecting rows, but not just on the basis of the index, rather than how they satisfy some kind of condition. And you can write a condition by yourself, and most common examples that I can mention, for example, let's return all the temperatures that are above average, or let's find the days that have humidity below 50%. Or, for example, let's see on what days it rained the most, or it rained the least, or some type of logic similar to these examples. This continues on this selection that we discussed before, because it used the same syntax. So the filtering is also done using square brackets. Within, you have to write your condition. The condition should have operators and one operator and multiple operands. So, for example, you can compare your column with some kind of number. So you can say if the values within this column are less than or bigger than or equal to. I don't want to confuse you too much just by talking about it, so I can show you an example. So, for example, I want to find what days were warm days, and I can define the warm days however I like. For example, I can say the warm days are the days that have temperature above 18.5 degrees Celsius. So I first need to define other data frame. So I can save the filtered data in that other data frame. I will call it warm days. So it will also be a data frame, but it will only include the days that have the temperature above 18.5. So the syntax is maybe weird at the first. Why is it weird? Because it repeats the data frame name twice. So I write it here and also here. But the syntax, you can look at it in this way. So this wider data frame is the name of your data frame, and it opens and square brackets here and close the square brackets here. Within these square brackets, you need to provide a condition, and the condition usually also includes the name of your column or all the values within this column. And how do we select all the values within this column? We already did that before, so I can scroll it back in this way. So using the name of the data frame and the square brackets and the name of the column within the square brackets, I'm indexing the data set by column. So I'm selecting all the temperatures within the data frame. And I now want to compare all the temperatures with the threshold I decided to use. And this is the logic behind of this syntax. So I'm first selecting all the temperatures, comparing them with the threshold, and then this is a condition, and it will give me, maybe I can just copy this first, and I will copy it in the its own cell. So to show you, it will give me a list of Boolean values. Boolean values in programming are just false and true values. So it will give me almost the similar result as the structure as I would get if I just write this. So I will get this kind of series with 6 temperatures with actual values. But if I compare them with some kind of threshold for each temperature will be compared with that threshold, and for each temperature I will subsequently get an either true or false value. So here I will get false, true, false, false, true. So basically only these rows are, let's say, warm days, and this result will be used for indexing the whole data frame. So that actually means, let's first find what days satisfy this criteria and select only rows, or here days, or measurements that have true value, true. So warm days, I have to print it. Warm days, or maybe warm measurements, are these three. So on station A and on 2 days on station C, because the temperature is above the predefined threshold. So maybe the syntax is weird, but perhaps try to remember it in this way. I am first looking at the values that I want to filter, then I write a condition near these values and put this all in the brackets for indexing the whole data frame. And then this odd structure at the end will give me only the rows that satisfy this condition. And you can write whatever condition you like. For example, I can filter the days where it didn't rain. Again, using the same syntax, just by writing a different condition. So again, I have to twice write df, and in brackets of the internal df, I have to write what column name I want to filter, and with what type of condition. So I want to look at the measurements that have 0 rain. And then if I output it, I will get only the measurements with 0 millimeters of rain. And what is even more useful, you can combine those conditions. So you can write multiple conditions at the same time. For example, I can only look at the hot days with no rain. So the days with the temperature above 18.5 and with 0 millimeters of rain. So naturally that condition will look, so that syntax will look more complex. But let's analyze it. I just combine this condition from this code cell, so this one, and also this one from the second. And how did I combine it? I put them for the syntax purposes with the inside their own parentheses, and combine the parentheses using this and sign. And sign in programming typically represent AND operator in logic. So AND is, it will give you a true when both sides of that both operands are true. So I will get a subset of my data where the temperature is larger than this value and where the rain is equal to this value. What do I have? Actually, these kind of measurements. Yes. So these two measurements. So from station C, it did not rain on station C, and on both days the temperature was larger than 18.5. And you can combine multiple more conditions. Your code will look more complex, but it is like that. I can't help you with that, but I can help you with the understanding of those conditions. So let's focus first on what is inside each parenthesis, and then what operator is here. And you can put some other operator. You don't have to write sweet. Okay, so I have to because I use so many programming languages, it takes me a couple of seconds to remember what is the syntax for OR operator. So instead of AND, I can use OR. So I get a different type of condition here. So I get both the days where the temperature is above this value and both the days where the rain is equal to 0. So I filter the dataset in different ways. So I get 4 measurements, both hot days and the days with 0. So this is actually only only this measurement. It doesn't satisfy this criteria, and this measurement it doesn't satisfy this criteria. So if I once again put AND here, these 2 measurements will be eliminated. Okay, so you can play with your conditions. You can write your own logic, but you will have to select the column and the value you want to filter on, and after that operator, how to combine those conditions. So either you will use AND or you can also put multiple hierarchies. For example, put some conditions together in some AND, and then after they figure out each other, then they are compared with some other condition and so on. But I don't want to over-explain this thing and make it look too complex. Maybe you can try it by yourself later. Okay. One thing to also to show today is for sure sorting the values. So sorting, I think you all know what does it mean. So sorting means sorting the data frame in some kind of way, but you have to define the way you want to use. The by default sort method uses columns, but you can also use the rows, and I will show it to you. So for sorting, we use the method called sort values. So on our original data frame, I can sort the values by, and I have to write like this by, because this is parameter of the method sort values that expects some column name, for example, temperature. So this is a column name that I want to sort on data. So after by, I don't have to actually provide any other parameter, but usually what is preferred is to explicitly state, do you want to sort it ascending or in descending order? So ascending means if you state ascending false, that actually means that you want to in descending order. And what does descending mean? So from higher value to lower value. So if I run this, I will get rows sorted by temperature. So the highest temperature is on top and the lowest is on the bottom. And if I write ascending true, then the opposite, I will get the opposite. So the lowest is on top and the highest is on the bottom. And I think this is fairly simple, but it can be more complex if I combine multiple columns. And what does it mean? So if you first look at the first column, and sort it, sort the values based on the values within this column. But if two values have if the two rows have the same value of that column, then the sort method will look at the other column and figure out the sorting order using the values from that column. We don't have here the temperatures that are identical. So to simulate this, I will first put the some other column that has the same values, for example, station, because I have two stations B, two stations A, two stations C. And then one may ask how will it sort the station values, because they are not numbers, they are letters, so it will sort them alphabetically. If you write, if you put it in ascending order, that it will go from A to Z, and if you put it in descending order, then it will go in other way. So if I write the station column here, the first, so it will sort all the rows alphabetically. And after that, if the two values, so if the two rows have the same value for the station, and this is the case because there are two A station, two A, B, two C, then we can use some other station, some other column to break ties. So for example, I can write humidity. I can just run it like this. So let's see what we get. So the rows are first sorted alphabetically by station, and then within each station they are sorted ascending in terms of humidity. But I can play with that also, and I can provide another I'm sorry, another parameter here that will correspond to each of the columns in parameter before, and I can, for example, write false true. This means that the stations will be ordered in a descending order and humidities in ascending order. So let's see what we get. As I said, it will return dataset order like this. So the station C comes first, but this row that has humidity 54 is before this with 55. Okay, so you can also play with these parameters however you like. Maybe put multiple columns, multiple ascending parameters, and so on. So this is all, I think, pretty much when it comes to sorting. You can also create new columns, and creating a new column is really easy to do. Just write the name of your data frame and put a new column within the parameter. So for example, the most basic way to do is like this. So for example, I can add one different measurement. I have to figure out something at the top of my head. So I don't know. Quality, for example. I don't know. Let's say we have some measurement of quality of air, and it can go from 0 to 1. And I can say for each of the 6 rows, for example, the 0.6, 0.4, 1, 0.7, 0.8, and 0.2. So if I return df now, it has one other column. So adding a new column is really simple. Just write the name of the column of new column in the parentheses and provide the values. And it is done often, but not maybe in this way when you put the values by yourself. Rather than new columns are added usually as perform some kind of operation, mathematical operation on the existing columns. For example, let's say I want temperature also in Fahrenheit, so I can make a new column, temperature underscore F, that uses the existing column and within the formula for transferring Celsius to Fahrenheit. So I get a new column that has I have to print it, that has this new column, so temperature underscore F. And these are the values that are calculated from these values. So I get a new column. Or you can, I don't know, make translate humidity to percents or this to some other measurements and whatever comes to your mind. So adding a new column, it all comes down to just writing the name of the column in within the square brackets, and after that, after the equal sign, providing the values for that column. And how will you provide the values for that column? It depends. It you choose however you want to do that. So you can either write actual values, or you can put some existing column within some formula and use the values from that column to calculate new values for new column. Okay, so each row within the temperature column will be multiplied by this number, and then 32 will be added to that result, and then that will be performed for each row. Then that is why we get multiple rows, even though we write only one formula. So this formula is applied to all the rows of the temperature column. Okay, that is how the new column is added. That is how the new column is added, and also we can rename columns, existing ones. So using the method rename. For example, let's say I want to rename the column. I will just copy from the GitHub. So let's say that I want to create a new data frame that uses the existing data frame, but the column rain underscore mm is translated to renamed to rainfall. So there is no significant difference, but this is just for to showcase how the rename method can be used. So if I write the rename, so new data frame, see how the previous column is renamed. So by using the rename method, I get a new data frame that has renamed previous column. Okay. I know maybe I speed up a bit, but I think these things are quite simple, and I don't want to over explain it or explain it to you to make it look pretty complex, because it really isn't. So it all comes down to just using the methods in appropriate manner. So here, by renaming, you just have to provide previous and new names of the columns. Okay, and the last thing that is most complex in Pandas is grouping and aggregation. It is at the same time the most complex technique that Pandas can do, and maybe also the most useful, because often you get a bunch of data, so your data set can be quite large, and you want to derive some conclusions from this data based on some groups. For example, if you look, imagine a quite large data set of this structure that we explored today. So we have some measurements of temperature, humidity, and rain for different stations and different dates. And let's say you want to conclude in this month the average temperature was this, or the it rained more on station A than it rained on station B, and these types of conclusions. When I say each of these lines, I did some type of operation in my head that maybe comes by default for a human, and that is called a grouping. So you group together multiple rows, multiple instances, and then calculate one value for all those instances inside the group, and that calculation can be called aggregating. So I first grouped multiple values inside my head and then aggregated, and then use that aggregated value to represent a whole group. So for example, I grouped all the instances, all the rows that has the same month together, and then calculated an average. And then I said, okay, in that month, for example, in May, the average temperature, it was 20 degrees Celsius. It is the fairly human thing to do, and also the analytical thing to do. And we want to now learn how to do it in Pandas. So Pandas offer us ways to do that, and they are not so complex. So methods to do that are not so complex, but we must understand what are we doing. So we want to, I will repeat it once again. We want to first make some groups of data within our initial data set, and after that, maybe after that, we will represent a group with some other value. That means we will perform some aggregation on that group. So the first step is to perform grouping, and then then aggregation. And grouping is performed usually on the column values. So the grouping implies that multiple rows share some value of some column. And if we look at our data, for example, we can see that there are no rows that share the temperature values. We can maybe say that if the temperature is between some range, the differences in some range that can we can look at that as the same temperature. But if we are strict, there are no identical temperature. There are also no identical humidity value, and also quality, because I made it up. But for example, we have some multiple rows that share rain values. So there are three measurements without rain, and also we have three measurements with the same date, and also three measurements with the same but different date than the previous one, and also have three different stations. So we can group this data in different within different columns, and the most obvious choices are station, date, and maybe rainfall. the reason for that is because only these columns share the data, so we can find multiple rows that share the same values of that column. But maybe if we had a larger data set, maybe we would find similar or identical temperature values also and humidity values also. But that is not the case here. So we can do the grouping either on the station, date, or rainfall level. Let's do it maybe on the station level, as this is maybe the most natural choice. So let's say that we want to calculate the average of each station, so we can compare the station by themselves. So how would we do that? So first we have to use our data frame and call a group by method and state the name of the column we want to use for grouping. So we want to group the dataset by station. So the dataset will now be grouped in 3 groups: the station A, station B, and station C. And within each group, we will have only the rows that correspond to that station. After that, we can make some aggregation, because if we just print this out, we will get some object. It's not anything that we can examine. So there are no values shown. So we have to perform some aggregation on the grouped object. The aggregation can be either by using internal functions in Pandas, or by writing our own function. Let's for start use the simpler method, and that is to use internal function. So we want to aggregate, for example, let's say we want to calculate the average of the stations, but we have to define average of what. So now when we use the station for grouping, all other columns are left for aggregation purposes. So we can use, for example, temperature column to do aggregation for all stations, stations A, stations B, station C, or we can use humidity or rainfall, quality, or temperature F. So any other column can be considered for aggregation purposes, and let's use temperature one. So we can now select by temperature. So use in square brackets the name of the column, temperature, and use the internal function called mean that represents mean or average value. So if we run it, we will get a really nice and short data frame that has only 3 rows, and that are the names of the groups. So these actually serve as indices now. So the names of the groups are indices, and the values are aggregated values. So how did we perform aggregation? So we use the temperature column and mean function. So we calculated mean, but we don't have to calculate mean necessarily. So mean is the first thing that comes to my mind. That is like average temperatures. For example, we can calculate minimal. So we can find what is the minimal function for each station, or we can find the maximum function for each station, or I don't know, median, and so on. So standard deviation, I don't know what other internal statistical measure comes to your mind. So these are internal functions that you can use for aggregating, but you can also write your own method. So for writing your own method, that is maybe out of the scope for today's workshop. Maybe we can have a look at it in next, but I will just start it. So we have to write aggg method here, and within the parentheses write this curly parentheses and I'm sorry, write here some lambda function, and I'm not sure if you used a lambda function or maybe define a function before. I did not prepare actual lambda function for now, so maybe we can leave it for you to think by yourself about some kind of function that you want to use for aggregation purposes. But given that we only have 6 data and only 3 measures, so basically 2 data within each station, there are not a lot of functions that we can use to analyze the data. Maybe we can do some kind of regression, modeling, clustering, I don't know, machine learning stuff, inferential statistics, and so on. But you will have to write your own code. And I think that is maybe out of scope for this workshop because it deals with the basics. But it doesn't have to worry you because in most of the internal function are used most of the times. So I can write again this mean. So what I can repeat what we did here. So we first selected the column that has some shared column values to do the grouping and then temperature. So somebody Mia write so I can maybe so okay okay you wrote here your own function for normalizing. I think this normalizing method I can paste it here. Just give me a couple of seconds to go paste it. And see what we get. Okay, so thank you, Mia, for your comment. It works, so you can see. So we normalized the value within each group, so we get some normalized value. But I'm not really sure what is the purpose of that function because we just I don't know. Okay. What would represent this number represent? Okay, this is just an example. Okay, this is an example of how the structure of the function should look like, and it is a nice example, and thank you. But maybe in terms of the logic behind of that value, this is something that we can also work upon because we want to have some number that represents the whole group. And the most obvious choices are these simple internal functions as average, median, mode, minimum, maximum, and so on. But you can think of some other function also. And one thing that I also want to show you is that you can combine multiple columns for aggregation purposes, so it doesn't necessarily have to be only the temperature column. So I will copy once again this code from GitHub. So it is only extended in relation to the previous by using these 2 columns, so humidity and rain. But for each column, we calculate the mean value. So we also aggregate by groupings a level, but represent here temperature, humidity, and rain. So the average all these 3 columns. So we now have all the 3 measurements averaged for each of the station. And this looks like a quite nice result of today's workshop because initially we had maybe at first weird structure of different types of measurements and with different station dates, temperatures, humidity, and so on. And at the end of the lecture, we got nice, simple, grouped and aggregated data frame that shows us for each station what is the average temperature, average humidity, and average quantity of rain. So we can compare these stations using these aggregated values. Okay, so I came to the end of today's workshop. I have one other section that is called guided practice that I developed for you to try the things that we discussed today. But I think that we can now we can leave it to you to do it by yourselves whenever you like. And if you have any question regarding that, I will just write here my email in the chat, and you can contact me. Feel free to contact me if you have any question. But I'll also provided a solution at the end of the GitHub or the Jupyter notebook. So I suggest that you start by your own without looking the solutions. If you want to maybe try the things we learned today, and if you're stuck, you can of course look at the solutions. But if you look at the solutions and you're still not sure why is it done in that way, feel free to contact me, and I will give you the explanation.